Hi everyone, my name is Paco Gonzalez and I'm an IoT Specialist Solutions Architect. Now today we're going to talk about how to use AWS IoT ExpressLink as a client device with AWS IoT Greengrass v2. The agenda is basically a two-part session. Part one, we're going to talk a little bit about the theory, a little bit about how ExpressLink works, how Greengrass v2 works, and then we're going to jump over to a demo hosted by Nicolas. All right, let's get started. Internet of Things has opened up the opportunity to collect and make decisions based on real-world data that is acquired via many sources. This data could be anything from how much water is going through a pump deployed in a remote factory to what kind of vibration occurs when your fridge is working to keep food cold. However, connecting IoT devices and transferring this data to the cloud can be a difficult task, one that requires deep domain knowledge on device connectivity, deployment, and management. Not only that, but you also need to account for the time it would take to build a complete hardware and software solution. After you're done through these tasks, you also need to think about the limitations to what data can you collect due to privacy, cost, or even physical constraints. This kind of means that you really need to find a way on how to keep data processing closer to your IoT devices. AWS IoT ExpressLink and AWS IoT Greengrass can be used together to provide local messaging capability and the ability to filter or aggregate data before sending it to the cloud for further processing. Just a quick reminder about AWS IoT ExpressLink. This is a solution that comes with connectivity firmware and hardware that implement the AWS specification to ensure your devices are connecting securely, whether they connect to AWS IoT Core or another MQTT broker. A quick reminder about AWS IoT Greengrass. This is an open source edge runtime that IoT devices can connect and send data to in order to process that data locally. It can be used to connect all of your IoT devices to each other locally and intelligently determine what data should be kept locally and remotely. In this video, we will show you how to connect AWS IoT ExpressLink module to an MQTT broker running on the AWS IoT Greengrass core device. We will detail what steps need to be taken to enable this connection and demonstrate how to publish data from an AWS IoT ExpressLink device to an AWS Greengrass core device, which can then forward data to AWS IoT Core in the cloud. Let's talk a little bit about the AWS IoT ExpressLink configuration. AWS IoT ExpressLink modules are equipped with a pre-provisioned hardware root of trust. This provides the necessary unique identifiers of the module and a key pair, a public key certificate that includes the public key, identity information about the owner, and the name of the issuing certificate of authority, or CA. The CA was actually previously shared with AWS as part of the program. The modules use a configuration dictionary, which is essentially a key value store that contains all the options necessary to configure the device. Some of the configuration key values are meant to be persistent across reboots, and some are writable while others are read-only. In this video, we're going to discuss how to configure the module to communicate with a custom MQTT broker by changing the keys endpoint and root CA. For more information about the different configuration options, please visit the AWS IoT ExpressLink Programmer's Guide and take a look at the configuration dictionary page. the endpoint configuration option is writable. It comes pre-provisioned with an endpoint URL pointing to a staging AWS account. This is because AWS assigns to each ExpressLink manufacturing partner a dedicated staging account. Now, this feature is designed to facilitate onboarding of new devices, but it will not be used in this video. Check out the Onboarding by Claim Customer OEM guide to learn about how to leverage ExpressLink module's unique onboarding capabilities. The root CA configuration option is writable. It comes pre-provisioned with a long-lived AWS server root certificate that is used to validate that the module is connecting to the intended endpoint during the TLS connection setup. A different certificate can be provided by editing the configuration option via the AT command interface or the OTI mechanism. Note, contents of the root CA configuration option are not to be confused with the root CA used to sign the device certificate. The first one is designed to prove that the device is connected to the intended endpoint, whereas the second one is designed to prove to the endpoint that an approved device is attempting to connect. Both work together to ensure they can mutually trust each other. AWS IoT Greengrass provides and maintains pre-built components that you can deploy to your devices. You can deploy these components to your devices for their standalone functionality, or you can use them as dependencies in your custom Greengrass components. In this video, we will be using the following components to enable local MQTT connectivity with the AWS IoT ExpressLink module. Number 1, MQTT broker. Number 2, client device auth. And number 3, the MQTT bridge. The MQTT broker component handles MQTT messages between client devices and the Greengrass core device. Client devices are local IoT devices that connect to and communicate with a Greengrass core device over MQTT. You can connect client devices to Greengrass core devices. This message broker actually implements the MQTT 3.1.1 protocol, making it suitable to send and receive messages with AWS IoT ExpressLink modules. Before a client device connects to a Greengrass core device, they can use the Greengrass cloud service to retrieve information about Greengrass core devices to which they can connect. The client device auth component is responsible for authenticating client devices and authorizing client device actions. We will be using this component and the related APIs available in the cloud to retrieve connectivity and root CA details needed to configure the ExpressLink module. Lastly, note that messages that are processed by the MQTT broker cannot by default be processed outside the broker. The MQTT bridge component can be used to relay messages between client devices, the local Greengrass publish subscribe IPC service, and the AWS IoT core. All right, so that was it for the theory. Now let's jump over to the demo with Nicholas.
Hi everyone, my name is Nicholas Switzer and I am an IoT Special Solution Architect here at AWS. And today I'm going to go over a demo on how to connect your AWS IoT ExpressLink module to an MQTT broker running on AWS IoT Greengrass. So to accomplish this, we'll use a combination of the AWS IoT console and AWS Cloud Shell. So the first thing we need to do is pull our Greengrass core device CA certificate. Now, if you're not familiar with the certificate, it's used for communication between core devices and client devices, specifically for mutual authentication. So we'll need this to actually allow our ExpressLink module to communicate securely to the MQTT broker running on our Greengrass core device. So the first thing we'll do is we'll create a Greengrass core device in the AWS IoT console, which I've already done here. I call it NISWC GG Pi. It's just a local Raspberry Pi that's running Greengrass core software. And on here, I've configured a client device that's associated with the core device. So this isn't the ExpressLink module itself. It's just a client device I have specifically for the purposes of calling the Greengrass Discovery RESTful API. So I'm going to use the credentials of this device, this GG client device-1, to call this API and pull down the Greengrass core device CA certificate. And we'll take that certificate and we'll save it over into our ExpressLink module to use for communication purposes. So to use the API, we can just use a simple curl command, which we have up here. So this is the curl command I've ran in the Cloud Shell, and this is the Greengrass Discovery RESTful API. So this API allows us to discover all of the Greengrass core devices and their associated certificates that our client device can connect to. In this case, I'm using credentials of this GG client device-1 device. And I'm using those credentials to connect, query the API itself, and pull back all the different certificates. In this case, there is a default Greengrass core device CA certificate, and that's what we'll be using here. So you can see I got the response. This is the actual certificate here. And what I'll do is I'll take this, copy it out, remove all these little new character lines, and I'll use the certificate itself on the ExpressLink module in the next part of this demo to configure that ExpressLink module and allow it to actually perform mutual authentication with the MQTT broker running on the Greengrass core device. So that's step one. I can take this certificate, you can store it anywhere you want, throw it in Notepad, just have it on handy, and go ahead and remove this new line character from the entire certificate itself. So the next piece we need to do is go back to our Greengrass core device. So core devices, I'm at my core device itself in the AWS IoT console. And then I have under here MQTT broker endpoints. So right now, your AWS IoT ExpressLink module can't connect to an IP address by itself for connecting to the actual MQTT broker. You need to actually connect to the host name of the device, and if that's not in your manage endpoints, you'll actually have to manually add that in the IoT console, or you could accomplish this via the AWS CLI as well. So for now, we're going to do this via the console, and all you have to do is click manage endpoints and add your host name with the default MQTT port of 8883. So my host name is ggpi1.local. And as always, we recommend before you add this and even connect to your ExpressLink module, go ahead and make sure on your local network that this host name resolves to the exact IP address and the exact device that's running your Greengrass core device software, as well as your MQTT broker. That way you just 100% know your ExpressLink module is connecting to the right endpoint. So I already have this here. If you didn't have this, you could click add endpoint, add in the host name itself, add in the default port of 8883, and click update. But for now, I don't need to do that. So I have this here. And next, all I'm going to have to do is configure our AWS IoT ExpressLink module. So we've done everything we need to do here for our Greengrass core device. We have a certificate. We've configured our host name under our MQTT broker endpoints, and we're good to move to the next step. Step 2, which is to configure our AWS IoT ExpressLink module. And to do this, we'll use a combination of @commands and a serial terminal. So for this demonstration and just for testing purposes, I'm using the Google Chrome Labs serial terminal web application. And then the first @commands that we need to run deal with setting up the connectivity for our device. So I'm using a Wi-Fi based ExpressLink module. So I'll need to set the SSID and passphrase to connect to my local network. That's just these two commands which configure these two parameters in our configuration dictionary that lives on our ExpressLink module. So for this, I've already gone through and configured these two parameters. I just wanted to make sure if anyone is using a Wi-Fi based ExpressLink module, they run these two commands and can verify that they can connect to their actual local network first. So to clear the output, I'll go back through and refresh and reconnect back to my ExpressLink module. And the next thing I'll do is actually run the endpoint configuration command to set our new MQTT broker endpoint to the host name of my Greengrass core device where my MQTT broker is running. Usually this will be set to the data endpoint for AWS IoT Core, but since we're retargeting for AWS or an MQTT broker running on our Greengrass core device, we can set it to the host name of our Greengrass core device. So I'll run this, get a response of OK, meaning that it was configured correctly, everything was good. If you get an error-based response, we do have an entire troubleshooting section that we'll include in the comments, a part of our documentation links that you can go through and check to see what exactly went wrong, but you should get an OK response here. Next, we'll actually use the root CA command, which looks like this, to configure our certificate. So this certificate is what's going to be used to actually connect to our Greengrass core device for TLS purposes, and it is usually used to connect to AWS IoT Core. So the certificate that's actually stored by default can be used for connecting to AWS IoT Core, right, from a TLS perspective. And that's why this is, the root CA is what we're replacing. This is not the actual device certificate or anything like that. This is just for TLS. So we're now going to replace this with the certificate we obtained earlier, which in my case was the below. And if I hit enter, okay, so I've got a responsive OK, which is exactly what I was looking for. I've set my root CA certificate now. Now I can run my @connect command. I'm going to OK one connected. That means I have fully connected to the MQTT broker running on my AWS IoT Greengrass core device. So it's not connecting to AWS IoT Core anymore. It's connecting to that local MQTT broker. So now all we need to do is test out this connectivity, and I'll demonstrate what exactly it looks like in terms of what messages can be sent to AWS IoT Core, as well as what messages are kept locally on that MQTT broker that's running on my local network. Our final step, which is to view live data coming from our AWS IoT ExpressLink module and passing through our local MQTT broker running on AWS IoT Greengrass, that will then be relayed up to AWS IoT Core. So to start, we're going to view our messages via the MQTT test client. So we'll go over here to MQTT test client under the AWS IoT console, click on subscribe to a topic, and the topic we'll actually subscribe to is the EL client pound topic, right? So this pound is a wildcard, so we're saying we're subscribing to all topics that come after EL client. And the purpose of doing this is to show that we have configured on the Greengrass core device only certain topics that can relay messages to AWS IoT Core. And we'll see that in the demo in just a second. So before I go through and subscribe, I should note here that all messages from our ExpressLink module are ATC encoded. So if you're sending anything that's not JSON data, let's say like binary or any type of string payloads, you'll want to actually break down this additional configuration and click on display payloads as strings under MQTT payload display, just to make sure that the console is not throwing any errors and everything gets displayed correctly. For now and for this demo, we're just sending all data as JSON payloads, so we can keep this just how it is. I can click subscribe, and I'm now subscribed to all subtopics of EL client. So the next thing I'll do is configure a topic alias of 1 for EL client subtopic. And this is topic alias of 1 here. You can see I can use my 1, a part of my @ command. So I configure this. And then I can send a message to this topic alias of 1 by using the send command and specifying the alias after the send command, which is 1, and that'll send it to this EL client / subtopic, which is a good topic that we've configured our broker to relay over to AWS IoT Core. So I hit enter, and there it is. So now I'll configure another topic alias of 2 with EL client bad subtopic. And because we've only configured we've only configured the EL client subtopic to relay messages over, this bad subtopic won't relay any message over to AWS IoT Core. So I can send the message off and it works correctly, and it's sent over to our local MQTT broker running on our AWS IoT Greengrass Core device, but it's not going to relay up to AWS IoT Core. It's going to keep all the communication nice and local, and that's all because we've configured our broker to not relay any messages over except for messages sent to EL client subtopic. So this allows us to keep a lot of this communication local. Other client devices that are on the same network as the ExpressLink module can all communicate with each other via this MQTT broker running on the Greengrass Core device, but we can specify what exactly it is relayed back to AWS IoT Core, which is exactly what we did here. So that concludes our demo of connecting an AWS IoT ExpressLink module to an MQTT broker running on AWS IoT Greengrass.
Thanks, Nicholas. That was a great demo. So as a summary, remember that you can use AWS IoT ExpressLink to connect to AWS IoT Core directly, or you can modify the AWS IoT ExpressLink configuration to point to a different broker. In today's example, we used the Greengrass v2 as the target for that endpoint, and essentially what we did was send messages from AWS IoT ExpressLink over to Greengrass v2 locally, and then we configured AWS IoT Greengrass v2 component to relay a specific message or messages that basically arrive into a specific topic. And so last but not least, please look out for the links in the description. They are basically pointing to relevant documentation that will help you understand and learn more about Greengrass v2 as well as AWS IoT ExpressLink. Thank you.